So in this second set of lectures, we're going to introduce some more detailed concepts about how to plan and schedule projects. So we're going to introduce something called the work breakdown structure. We're going to talk about scheduling and network diagrams. So I'll try to split this very long lecture into two, but we'll be talking about matters which relate directly to your second task. So where are we? We've already completed your first lecture where we talked about project planning, and in this second set of lectures we're going to talk about scheduling. Later on we'll talk about risk and cost. So by now you should have completed task 1. So that you should have done, and you should have completed task 0, your SMART objectives. You should have completed the resilience questionnaire, and you should have started on the peer moderation of both of these. So peer moderation of task 0 and peer moderation of task 1. So you can see we're very quickly ticking through all the activities here. So your next big activity is going to be your second task, task 2. So this is worth 15%. Followed very quickly by your first class test, worth 15%. So just these three between them, plus the task 0, that's 50% of the module. So 15, 15, 15, and 5. That's half of the module. So in the next few weeks, it's really important that you take these concepts on board. So where are we? So in terms of your virtual project, so when we talk about project, we're talking about your virtual project, your dinosaur park. So where are we with that? So you've completed task 1, so you know what you're doing, and you've completed task 1. So that's task 1 complete, and you'll be getting your marks for that very soon. So that's where we're at. What we're about to do is to engage in some proper planning, also proper scheduling, and that requires that we learn a few concepts and the use of some tools. So let's assume that the work you did, the SWOT analysis.
Sing another one. If you say, sing me another song.
And assume that your project has been approved, and assume that you have the funds. So what next? What happens now? Now is the scheduling phase. And for that, we need to talk about some of the concepts and tools that we use for scheduling and planning. So before that, let me play a short video clip that'll sort of set the context for the remainder of this lecture.
Work management can be difficult for many reasons: time, effort, people, problems outside of work, and the list can go on. One of the biggest reasons projects don't work out is because of the lack of planning. When a project doesn't have a well-orchestrated plan, or has a plan that is too demanding in scale for the time frame, things will go wrong, either causing the project to be worse than what it could have been, or not get finished at all. With better planning, every project can be a success. But what are some ways to make planning easier and more effective? Well, first off, we have a work breakdown structure, or WBS for short, which are chart and web structures that go in the order of biggest to smallest. The things that are ordered from biggest to smallest are the tasks involved in the project. These tasks are then put into categories and subcategories to create a hierarchy of importance. The higher a category, the more important it is in the grand scheme of the project. A glossary can also be created to give a short description for every task. This tells the reader what exactly is required and can be pretty helpful for everyone involved in the project as they have a clear idea as to what they need to do. A WBS is typically used at the beginning of a project to organize all the tasks together. Later on, it's possible for our second option to come into place, a NAT chart. A NAT chart not only contains every task of the project in order, but it also displays the amount of time needed to get the tasks done. The benefits of sticking with a WBS is that it's simple and easy to understand. This is the ideal format for smaller projects, where tasks can be easily understood and done. However, when the scope of the project gets bigger, it's definitely recommended to use a NAT chart. NAT charts take a bit longer to understand, as there is a bit more information to take in. However, once it's understood, this can be extremely helpful for someone to check on the progress of a project. Creating a time estimate for every task can let someone know whether the project is on schedule or not. A timeline can also be added to display how a task segues into another. Finally, NAT charts also contain something known as a critical path. The critical path displays the longest duration path for the project, and if any task inside the critical is delayed by 1 day, the entire project will be delayed for a day as well. These two charts are used all the time in many industries for all types of projects, big or small. They're very important for project managers, as it gives them everything they need to know about a project and if everyone is doing their part. With all that said, how does someone make these charts? Well, we'll fill you in right now. To make a WBS, the first thing you have to do is list the main tasks first, which are the things that come to mind to answer the question, how do we get this done? It doesn't matter how important these tasks are in relation to each other just yet, so just put down what you know. Once you're done that, take one of the tasks and see if you can break it down into smaller pieces to get down to the basics. Keep doing this for every task you've listed so far, and if something can't be broken down, maybe it can work inside another main task. Once you do that, check and see if it looks like all the smaller pieces are easily manageable. If not, consider breaking them down further. Do this in a way that the main tasks are on top with the smaller tasks below it. It's up to you whether or not you want to add a glossary to define what every task represents. Once you've done this, you can decide if your project needs a NAT chart. If it does, here's how you make one. This is the part where you decide how work will be divided over the chosen amount of time. You'll need to create a task list by updating branches, essentially choosing what needs to be moved or replaced. Next, you have to add an approximation of how much time is required to get a task done. These time limits are usually measured in days. Then, you have to link every task together in an order that makes sense. Remember to be reasonable with the time limit you assign to a task. You can't plant a seed and expect it to pop out of the ground overnight. Once everything has been listed, check to make sure none of it overlaps. It wouldn't really make sense to fertilize your field after the seed has already been grown. Finally, pick the right people for individual tasks. Go over their weaknesses and strengths so that if you give them something, they can do it well. It's common sense to not make someone in charge of something they're bad at, so do the opposite. It's also important to make sure not to overwork anyone involved in the project, since exhausted workers can often lead to delayed, or even worse, unfinished projects. By using a WBS or NAT chart, anyone can organize their project in a much better way, which can not only lead to a smoother process throughout, but it also raises the project's success rate and quality. Next time you plan on making a project, consider using these charts to make the whole thing flow a lot smoother. Thanks for listening, and we hope that you understand WBS and NAT charts.
Okay, so I hope you found that helpful. Now, you will already have come across this idea of WBS and breaking things down from large to small in two places. You will have certainly seen this in your final year project planning and also in your year 2 project. So the idea of breaking things down into work packages and then into tasks isn't new to you. But you also probably have started thinking about this for your virtual project, for your dinosaur park. And whether it's a small project or a huge project, how these projects are planned is critical. And as an electrical engineer, a future project manager, you need to have some awareness of how these things happen. So let's make a start looking at that. So, planning and control. You often see these words together, but they're very different. So any project we have needs a plan, but the plan then needs to be controlled. So these are two things that go together, planning and control. So part of the planning you've already done. It's setting the objective. What is it we're trying to achieve? When do we need to achieve that? And what are the specifications? Okay. So a lot of your scheduling will go into the planning phase. But then the control is necessary to make sure that what actually is carried out, the implementation, follows the plan. So that means always comparing where we are with your planned performance, reviews, and changes of plan as necessary. And we'll be talking about both of these for the rest of this series of lectures. So, first of all, a project plan. When we talk about a plan, what is it we want? We mentioned objectives, but before the objectives, you need an overview. The overview is sort of the 1 or 2 line summary. So before you chose your final year project, before you actually set your SMART objectives, your supervisor might have offered an overview, a summary of this project online. And from that overview, you determined whether or not you were interested. The general approach is how you're going to do it. Not in detail, but what are the general managerial and technical approaches? How are we going to approach this project? There are also contractual aspects and schedules, and we'll be talking a lot about the scheduling aspects. Okay, so we won't be talking much about the contractual aspects, important as they are, but a lot of this week's lectures and a lot of the activity involved in task 2 will focus on scheduling. So, what actually do we need to consider when putting together a plan? It's basically these 4 things: the resources, the personnel, how you're going to evaluate it, and an identification of potential problems. So this bit, risk, we're going to look at that in the next set of lectures in 2 weeks' time. Okay, so resources and personnel, that's what's available to you. Whether it's funds, or whether it's equipment, or whether it's staff, that goes in these 2 here. Evaluation methods, again, this is how you're going to check during the course of the project and at the end of the project whether the project has met its objectives, whether it's on track, whether it's performing correctly, whether it's going to be deemed a success or not. So you will have considered this already in putting together your SMART objectives, and throughout the project, as part of your control, you'll be looking at evaluation methods. And you need to do that because your project, whether it's your final year project or your dinosaur park, your project will be assessed at some point. And that assessment will rely on these evaluation methods. So you need to be clear on how your project will be evaluated. Because if what you have in mind and what whoever is assessing your project has in mind, if they're not the same thing, then that could lead to problems. So if you both agree on evaluation methods, that's fine. But if there's any discrepancy, that's where problems arise. So putting together a project plan. So I won't read all this to you. You can do that yourself. But I want you to focus on this bit here, the change order. This is where you have changes in a project scope. And this is what's happening in task 2. So you need to watch out for that. So there are two aspects to a project plan. One is a document that describes the project elements. That's what we were talking about in the video with the work breakdown structure. And the second is it's usually some kind of a diagram or a computer file that actually gives you the scheduling detail. So your WBS and your Gantt chart or network diagram together with your text document describing all these elements, that is your project plan. And that is basically task 2A and B. So this is a reference. I have this up on Vital for you to look at, or you can find it yourself. And there are other similar references you can read that gives you an idea about how all these things fit together. So the key ingredients to a successful project plan are communication. You've probably already seen how vital it is to the success of a task for the team members to communicate with each other. So some of you might have almost missed a deadline for task 1 simply because there was poor communication. It's also important to have a clear mission. What is it you're trying to do? So your objectives need to be really clear. Top management support. So in the case of your final year project, that would be your supervisor. In the case of this virtual project, it could be the module coordinator, or it could be the company senior management. It could be the authorities. But really important, and important for today's session, is the schedule. So unless you have a plan or a plan including a detailed schedule that details what's happening and when, using what resources, it's almost impossible to complete your objectives on time. So, as you saw in the video, to successfully plan a project, you need to be able to catalogue or list all the individual elements of work, how they depend on each other, and how much time they'll all take. So these are the 3 elements: communication, monitoring, and control. So think of something huge that you've seen recently. So previously I would use this example for time-lapse video of a 30-story building being built in 2 weeks. Now 2 weeks, that's the time it took you to do task 1. So you did task 1 in 2 weeks. And these people built a 30-story building in 2 weeks. And that's incredible. But last year, or earlier this year, this 1,000-bed hospital was built in Wuhan in 8 days. Now think, what can you do in 8 days? If this 1,000 bed hospital can be built in 8 days, think of how much planning is involved in that. Now, for the rest of today's session and the next lecture, we'll be looking at how we can adjust and manipulate our plans to make things like this happen. So this isn't a miracle. This is a feat of engineering, but it's not just technical engineering. It's the project management. This is a project management success, and this is really what I want you to think about. So again, I'll share this little video with you. It's just 1 minute.
If you've deferred your debt payments because of the pandemic, your interest is mounting up. But if you owe more than £6,000,
So think about the thousands of people involved in this enterprise. Think about the amount of scheduling and planning involved in making this happen. It's a huge undertaking. But don't think of it as a technical achievement. Don't think of it as an engineering achievement. It's a management achievement. Think about how many individual subcontractors, how many companies are involved here. So we'll be looking at how that can be made possible. So we'll start with a plan. We'll represent that graphically as a network diagram. We'll talk about the work breakdown structure, sequencing of activities, and then estimating time. So let's get some terminology. Terminology just means the words we use to describe things. So let's agree on a few words. So first word, program. What we mean by a program is some large activity. Some large activity that is there to meet a long-term strategic objective. That program could be building a 30-story hotel. It could be building a 1,000-bed hospital. That's a program. It's some large activity. And then that activity is broken down into projects. So you could have different projects as part of this large activity. So we already now have two terms, program and project. For example, we could have the space program. So NASA's Apollo space program is a huge program. It has strategic objectives. And in there, you have individual projects. These projects are generally smaller in scope, more limited, and they could be independent, or they could be interrelated. But for example, the lunar lander and the orbiter, they're closely related, but they're separate projects. So you can have different staff working on them. So in terms of breaking down in terms of the work breakdown structure, so breaking down your program, you're going from large to small. So as we go from left to right, we're going from large to small. Another example is we could have the development of Liverpool city centre. So a few years ago, we had the development of several projects in Liverpool city centre. So we had the Liverpool One project, we had the Echo Arena, And we had the Pierhead Museum. These were all happening at the same time, but they were all part of a single program. So your program is your large strategic activity, and that's broken down into projects. So you have a program here, then you have projects here. Now the projects themselves can be broken down into tasks. So each project can have individual tasks related to them, and the tasks can then be broken down into subtasks. So a task is an activity that has a clearly defined outcome. It's something which will deliver something. It has a clear time scale and it has a clear resource allocation. So a task is the smallest unit of work that we can divide things into. And ideally, a task is something that one person can be responsible for. So again, our example of Liverpool development, you've got a number of projects. If we take Liverpool Arena as our example project, that can be divided into hundreds or thousands of individual activities. Each of these activities is a task, right? So these are tasks. Okay, and this is where the idea of an organizational structure comes in, because you need to be able to structure all these activities and represent them in a clear way. So building something like this, just like building a hotel or a hospital, involves thousands and thousands of moving parts, thousands of individual operators, dozens or hundreds of companies all working together in the same place. So it's important to have some kind of organizational structure. So this is where the idea of a work package comes in. A work package is a way of organizing these hundreds of tasks. So instead of just having a project broken down into tasks, we have these work packages. You've probably already seen this as you started planning your final year project and your specification report, because your specification report will have involved work packages. So a work package is a sub-project that's a group of related tasks. So, a little bit more about this idea of a work breakdown structure. So, as we said, this is your first step, and this is how you get from a broad objective to a proper project schedule. So it's not enough to say, I want to build the Echo Arena, or I want to build a 1,000-bed hospital. It's getting from that broad objective to a detailed schedule that enables that to happen within a finite duration for a given cost. That's where WBS comes in. So you need to identify and catalog all the activities, organize them in some kind of a hierarchy, and then we will look at interdependencies and timing. So this is where we're at the moment. We have a program, we have projects, we have tasks, and work packages are just groups of tasks, groups of related tasks. So this is what we call an organizational hierarchy. And sometimes this is horizontal and sometimes it's written vertically. So what have we added here? We've added something new. We've added something called a deliverable. And we've added something called a milestone. And deliverables and milestones are similar, but they're different. Okay, so they have similarities, but they're different. And the tasks, these haven't changed. We've simply moved them to the right a little to show that these tasks are there to enable these deliverables to happen. So you've got a program, that was the top level. That leads to a project or multiple projects. The project will have a work package, or work packages, and then there'll be deliverables, milestones, and then there'll be tasks. So that's the general structure. So we have 3 levels, x, xx, and x.x.x, which is our 3-level hierarchy. Okay, this is the way we'll be looking at it in this module. Different modules or different models exist where you have different numbering schemes, but we'll be looking at work package being the highest level, deliverables or milestones being the next, and tasks being the 3rd level. So first level, or level X, a work package. Sometimes these are called project phases. So these are a number of groups of activity. So think about your final year project and think about what work packages you had. They're generally related to some deliverable. And then tasks are allocated within that. Again, a little video to help visualize that. Okay, so I hope you found that useful. Let's take an example. Say we wanted to build a house. Okay, so a really simplistic example where we have a number of activities. In this case, 8 activities to build a house. So you can scale this up and think about a 1,000-bed hospital. But let's just take a very simple example of building a house. These activities can't just happen all at the same time. They have to happen in a particular sequence, or at least some of them need to happen in a particular sequence. So how are we going to organize this? You can organize it based on deliverables. So a deliverable is focused on results or products, something that you can actually, that's something that's completed and you can actually hand over. You can actually deliver as a finished finished product. So it's a completed activity task and the result. Milestones are different. Milestones, so the word milestone, it comes from literally a stone that would be put in the road to show you how many miles down the road something was. So that's the history of it, but we now use milestones to represent either the past or future planning. So a company might use milestones to indicate progress. This is where we expect to be in 2014, 2019, etc. So milestone is something that you will have completed, or it's a phase that you will have arrived at. So it marks the completion of a significant segment. So you could say, I've completed the hardware design, I've completed the simulation, I've completed the documentation. That's a milestone. It's something that you've completed. So we expect several milestones per work package, but we say at the very least you should have a milestone at the end of the work package to say that that work package is completed. So you can see milestones and deliverables are similar, but they're different, because a deliverable talks about something which is completed and can be handed over. It's like a product. It's like an actual, it could be documentation, it could be software, it could be a contract, it could be a building, it could be a circuit diagram, but it's something that can be delivered. It's a product, whereas a milestone indicates the completion of some element or some segment of work. So for example, in building the house, a work package could be the utilities, and the utilities could then be broken down into individual level x.x, so second level milestone. So we could say the milestone is the gas service is installed, or the plumbing service is installed. Each of these is a milestone. So after you've completed it, you can sign it off and you say, we've done that. The gas services have been installed. We've reached that milestone, and we can move on to the next. So that's an example of x.x. So here, 4.3, that's where the x.x comes in. So tasks, that's your next level, x.x.x. So it's your third level WBS component. So tasks are the individual components of the work package that together form your deliverables or your milestones. And tasks can also be broken down into subtasks if the tasks are large. And you keep breaking it down until you have a task that can be completed by a single person, and that's your finest level of subtask. So for example, now we're getting down into the x dot x dot x. So you've got 3 levels. X dot x dot x. So 7.1.7. So that was your work package. That is your milestone. And these are your tasks. And each of these tasks may need to be broken down into subtasks. But for example, laying the carpet, that is a task. And together that contributes to the interior. So these are your individual level 3 components. So what we want is to keep drilling down until we get to one owner per task. So we can assign a task to a single owner. So we wouldn't say installing the kitchen equipment is a task. Even though it is a task, it isn't the lowest level of detail. What we want is something like connect the oven to the electrical supply, because we can assign that task to an owner. We can assign connect dishwasher to water supply. That task we can assign to a person. But install kitchen equipment, who's going to do that? We could say, okay, we assign that to the subcontractor, but the subcontractor isn't an individual person. So here you've got an owner, whether it's an electrician or an electrical subcontractor as a company. At least that's one owner to take responsibility for the task. Okay, and I have some videos on Vital, and there are plenty on YouTube to give you further clarification on that. So what we want when we define our WBS is a deliverable with measurement specified. So the tasks need to be defined so that the task owner can be given completion criteria. So it's not enough to say the cash register should be installed, but we need some way of determining whether that's actually completed. So we need operation certified. So something needs, a box needs to be ticked. So that's important when determining deliverables. Now, in terms of level of detail, when we talk about tasks, we've spoken about ownership, but also the duration of the task is important. You don't want huge tasks, and you don't want micro tasks. So sometimes looking at Gantt charts for final year projects, you see tasks that last 6 weeks. A 6 or a 7 week task, that's too big really. It's too big to enable useful planning. So what we want typically is a task duration at the lowest level to be less than 5% of the total project time. We don't want it to be 15-20% of the project time, because that's no longer a task. That now becomes a work package. So for example, what's 5% of a year? So 5% of 50 odd weeks is just over 2 weeks. So we want the largest task to be around 2 weeks. So the duration of the project will determine the largest task. So if your project is over 6 years, then your tasks can be longer than 2 weeks. But if your project is supposed to finish in 2 months, then your task really needs to be 2 days at most. So think about your final year project. So your final year project is at most something like 18 weeks. So what's 5% of 18? So that is how large your task should be. So think about your Gantt chart that you presented in your specification report. If you had a task lasting 5 or 6 weeks, then that is nowhere near that. Okay, so that isn't a hard and fast rule that you have to apply for all projects. But typically, if you want a well-specified WBS, and if you want to be able to plan it properly, you want your tasks to be less than 5% of the total project time. So, back to your virtual project. So, for task 2, you will need to put together a WBS. You'll need to do it on paper first, then you'll do it in software. Okay, I won't go through the details of task 2. You have the handbook and the briefing sheets. But you'll be using Microsoft Project, okay? So Microsoft Project will enable you to prepare Gantt charts and network diagrams. We'll be talking about network diagrams in a minute. There are plenty of video tutorials on YouTube and on Vital on how to do that. Watch out. Project isn't available on Teams, but it is available on the university network. And the two places to look for it are on Apps Anywhere and a remote teaching center. So probably the easiest way to get there is just on Apps Anywhere. Okay, so if you just go to the university site and look for Apps Anywhere, you can then log in remotely and access Microsoft Project. Excuse me. So you'll need this for task 2. Again, it's not available in Teams. Okay, so you won't be able to access Microsoft Project in Teams. It would have been nice if it was available, but this year the university hasn't made it available. So you'll need Microsoft Project, and it is available on Apps Anywhere. So now we're going to talk about project scheduling. So the first half of this was WBS. Now we need to talk about project scheduling. So scheduling is all about time. So it's all about sequencing and time estimation. Sequencing is the order of what happens in what order, and time estimation is how long do these things actually take. So again, back to our example of building a house. Remember we said we have these work packages from 1 to 8. Some things can only happen in a certain order. Okay, so these things are sequential. So some things you can't do until something has happened before them. Some things don't matter, they can happen at the same time. So again, keep thinking about that 1,000 bed hospital that they built in 8 days. Think how many thousands of tasks were concurrent. How many of those work packages were happening at the same time? But some things can't happen until others have finished. And that's what determines the overall time. This is what causes delays. It's when you have sequential projects or sequential tasks or sequential work packages. So for example, for building a house, obviously you have to start with the site preparation. You can't lay the foundations until you've prepared the site. You can't do the framing until you've done the foundations. You can't do the walls until you've done the framing. And you can't put the roof up until you have the walls. So these tasks are obviously sequential. That's obvious. But the utilities can be laid, they can be set while these things are happening. So these are called concurrent. Similarly, the landscaping, so this is the work in the garden, for example, the fencing, this can happen independently. So while the walls are being put up or while the roof is being put up, this can all happen concurrently. So all of this is also concurrent. But for example, the finishing might be concurrent with this, but you couldn't have had the finishing happening here because the walls were still not ready. So there are things called interdependencies. The interdependencies determine what things depend on certain earlier things to have finished first. And there are videos for this on Vital, and there are plenty of tutorials online. So, the next thing we need to look at when talking about scheduling is time estimation. It's basically, how long does a task take? We need that so we can schedule for efficient completion and to determine duration. Duration is how long the project will take from start to finish. And that's really important. So when estimating time, we often have three metrics. We have an optimistic time, a pessimistic time, and a most likely time. And these three are combined together in something called the expected time. So the optimistic time is the shortest time it'll take. The pessimistic time is the largest time, the longest time it'll take. And the most likely time is our best estimate of the time required. So think about any task you've been involved with, or say you had you asked somebody to carry out a repair for you, and you said, how long will it take? And they could say, well, it could take anything from 1 hour to 3 weeks. So the 1 hour would be your minimum possible time, the optimistic time. If everything is fine, if I find the fault, I have the parts ready and it's an easy fix, I can fix that within an hour and you're good to go. But if it's complex job, I need to order a part, I need to order several parts, I need several other people to get involved, I need to send it back to the manufacturer, it might take up to 3 weeks. But most likely, I'll be able to do it on the same day, right? So let's say my most likely estimate is 1 day. So when you're planning a project, what do? Do you use the 1 hour? Do you use the 3 weeks? Or do you use the 1 day? Which of these do you use? It's not enough to say, well, I'm an optimistic person, so let's hope everything works to plan, and we'll schedule all these tasks using the optimistic time. Or you could say, no, I'm a pessimistic project manager. Let's assume everything is delayed to the maximum possible, and we'll use the worst possible estimate. Pessimistic time, 3 weeks. Or should we use this? Well, it makes sense that we would use this, but we have to take into account the pessimistic time, because that's always a possibility. So what project managers usually do is weight that by 4. So we multiply the most likely time by 4, and each of the optimistic and pessimistic is weighted by 1. We add those together, and then we divide by 6. So it's sort of a weighted average where the most likely time is 4 times as likely as weighted 4 times as much as the minimum and the maximum. And that gives you something called the expected time. So the expected time is what we use in our scheduling. In your virtual project, you won't be doing this. You'll estimate the expected time directly. So let's take an example. You'll often see tables like this where you have activities and you have things called predecessors. A predecessor is an activity that has to happen before an activity can happen. So here, activity A doesn't have a predecessor, so activity A can just happen. And activity B doesn't have a predecessor, it can just happen. But activity C can't happen until activity A has happened. Activity D can't happen until A has happened. E can't take place until both B and C have happened. So we use this information to construct our network diagrams, and we'll talk about that in a minute. Right now, I just want to talk about the expected time. And remember, we said the expected time is simply 1/6 A plus 4M plus P. So you've got your optimistic, your pessimistic, and your normal time, M. So for example, task A might happen in 2 days if we're lucky, 6 days if we're not, but generally 4 days. So if you say 4 times 4 plus 6 plus 2 divided by 6, that gives you 4. The same if you look at task E. 5, 4, and 7. Again, if you multiply that times 4, add that, divided by 6, that'll give you that. So you can calculate the expected time from the pessimistic, optimistic, and normal times from tables like this. Okay. Same example again. This is the formula you'd use. So this gives us project schedules that enable us to put together our graphical descriptions. Okay, so your most probable, that's that. But we don't use this for our graphical descriptions. What we use is the expected time. So, the graphical display, what do we mean by this? What do these displays look like, and how do we use them? Well, there's more than one way we can represent our project plan. We can use a Gantt chart, and you're all familiar with that, or we can use a network diagram. You might be less familiar with that. But remember, at the beginning of this lecture, we said there are 3 things we want to do. We want to communicate, monitor, and control. These are the 3 things we're trying to achieve in project planning. And to do that, a WBS is very helpful, because the WBS includes your schedule, which contains your interdependencies and your timings. So the tools we use are Gantt charts and network diagrams. In this module, we will focus on network diagrams. A Gantt chart is a simplistic kind of illustration. You've seen these before. They're very helpful because you have your tasks, You have your timeline, and it enables you to see graphically very easily how big a task is, and it shows you the interdependencies, what tasks have to be completed before others. And it's really helpful because it shows you how you can, or how long a project will take and what would the consequence of a delay in any project be. So they are useful. Most people can easily interpret these. They're good illustrations of hierarchies, and it's easy for you to show milestones and deliverables on them. People don't need much training to understand a Gantt chart. But it's difficult to use Gantt charts for projects that have any level of complexity in them. You're unable to highlight risk, and really important for this module, important in project management in general, is it doesn't give you any idea of how we're going to identify these really important elements of critical path, slack, earliest event time, etc. So if I wanted to develop a complex project and I needed it to happen within a time frame which might change over time, with a large number of moving parts, a Gantt chart isn't the best way to do that. We can use the Gantt chart for communication purposes, but for project planning, Gantt charts aren't very effective. The alternative is something called network diagrams. Now, a network diagram allows you to show the relationships between tasks. It shows you task duration. It shows you, and this is important, which tasks are critical for on-time project completion. So it enables you to see something called the critical path. And that gives you the critical time. So really, this is how project managers actually plan projects. They don't use Gantt charts. Gantt charts are used for communication rather than for planning. So what we often say is that business executives prefer Gantt charts because at a business meeting, a Gantt chart is a nice and simple way to present where the project is at. But actual project managers, to make things happen, you need something called a network diagram. And we'll talk about that in a bit more detail. So, just back to this example. Do you think this 1,000-bed hospital was built using Gantt charts? Do you think all those, did you see the hive of activity, the thousands of workers operating on that site? Do you think a Gantt chart would be able to manifest all that complexity? So a network diagram. So remember the Gantt chart we looked at 4 or 5 slides ago? That Gantt chart is now represented using a network diagram. So what does the network diagram show us? It shows us the same thing. You've got your tasks or your activities, and you've got these arrows. And these arrows show you the duration. And they show you the sequence, and they enable you to see what constitutes the critical path. What are the things which actually determine the total duration of the project? Okay, so what we're looking at actually is a screenshot from Microsoft Project. So you will be creating the same kind of network diagram for your projects. Okay, speaking of which, tasks 2 and A. As you know, you will be working on some part of this theme park, and you will need to recruit and train your team, prepare the site, complete the project. I won't read all this to you. You're familiar with this. This is where work breakdown structures come in. So you need to plan your work packages, your milestones, and your deliverables. First on paper, then in MS Project. So first you need a work breakdown structure, then it all goes into MS Project. Okay, you can read all the details for tasks 2A and B. All the information is available to you on Vital, but it's all about knowing how to populate and manipulate these network diagrams. So task 2B is where these work change orders come in. So work change order is where the original specification has changed due to some event. In this case, unexpected event. There was an earthquake followed by a tsunami. Everything that has happened since the beginning of the project now needs to be reconsidered. Again, I won't talk about the task in detail. All of that's available on Vital, but really this is the background for task 2B. So you need to now review the WBS that you prepared in task 2A. You need to identify Slack, and we'll talk about Slack very soon, and then we'll talk about submitting the revised project plan. So this is task 2B. So task 2A and 2B are equally weighted, and together they form 15% of the module mark. Okay, so all of this detail is on Vital. Deadlines are all on Vital. 2A and 2B need to be submitted together, the same deadline, and all team members need to submit. Okay, the PM, the project manager for task 2A, and the project manager for task 2B, that's what we'll be assessing. So you've got a different project manager for each of 2A and 2B, and it's these submissions that will be marked, but all members need to submit. Okay, and there's plenty of further resources on Vital. Okay, some of these links might not work, but they were intended to link to online resources which may have moved, but they're easily enough to find. So the next part of this lecture looks at network diagrams, Slack, and critical path. So this is how we actually construct these network diagrams and how we calculate schedules, time durations, critical path, and Slack. We're going to talk about crashing and other ways of expediting projects.